Hello everyone, Namaskar. So let's solve one more question from partial differential equation, and this time we have a question where we have all the elements present: x, y, z, p and q. So it's going to be an interesting problem and an important problem to learn from. So let's open your notebooks and just give it a try with me. First step, as always, there are lots of steps in this if you are solving this by Charpit's method. So first step is bring everything to the left. So in books it is written this way: let function of x, y, z, p, q equals to, after bringing everything to the left, z square minus pqxy equals to 0. Okay. So this being our primary step. The second step is to write the Charpit's famous equation. So the Charpit's equation, what is that? Dx divided by something, dy divided by something, dz divided by something, dp divided by something, and finally dq divided by something. Here, as you know, x has affinity towards p, so minus del f by del p. Y towards q, so minus del f by del q. Multiply this by p and write, so minus del f by del p. Multiply this by q and write del f by del q. Here, both the terms have one term common, which is del f by del z. Del f by del z. P to p here, so repeat this p. Q here, so repeat this q. First term, because p has affinity towards it. Affinity means love. So del f by del x, del f by del y. Done. We have written successfully the Charpit's equation. Now our next target is to find these elements: del f by del x, del f by del z, and so on. So first, del f by del p. What is that? If you look at this equation carefully, focus on this. So first will be 0 because we will treat others as constant. So from here you will get minus of qxy, del f by del q. Again, first term derivative is 0, minus pxy, del f by del x. First term again 0, minus pqy, del f by del y. First term again 0, minus pqx, and at last del f by del z, which will be obtained from the first term, which is 2z. Now put everything in this equation. So del f by del p, qxy, minus minus plus, simply write qxy. Here again minus minus plus, simply write pxy. Multiply this by minus p, so minus pqxy. Multiply this by minus q, so again minus pqxy. So if you multiply this by del f by del p into minus p was there, so pqxy will be there with positive, pqxy with positive, so positive positive, twice I can simply write, so 2 times pqxy. Coming to this, del f by del x is minus pqy, del f by del z multiplied by 2z. So this is 2z multiplied by p. So 2pz, del f by del y minus pqx, q multiplied by del f by z is 2z. So 2z q. Q is there. Okay. Del F by del Z multiplied by Q. Del F by del Z multiplied by Q. So I don't think that these equations are sufficient for us. Just like Lagrange's method, when sometimes method of grouping was not sufficient for us, so there we use method of multipliers. So if you are looking your eyes at this, so y and y getting cancelled, okay, x cancel, but dx by q, dy by p you are getting. Can't be solved. So what we can do, we will try to eliminate things up. So qxy is there and a dx is there. Okay. Qxy. Qxy is there. Pxy is there. If I multiply this equation, I will have to definitely multiply this by p. So if I multiply first by p, so I will get p dx divided by pqxy. Okay. And now my focus is on this or this. Okay. So multiplied by p, so let's choose this. So this I will have to definitely multiply by q, both the terms. Okay. So if I am multiplying both the terms by p is there, q is there, y is there, x is missing. Yes. This is giving me a hint. Because x is missing, so multiply both by x and add. So x dp, this becomes pqxy plus 2pxz. Now these two are not in my radar. Now this is not in my radar. I have already used this, so my eyes are in the second one. Again I multiply this by q, so I will get q dy. From here I will definitely have to multiply by y, so plus y dq. From here you get pqxy. From here you get minus pqxy and 2qzy. Cancel. So let's see, p dx plus x dp divided by 2pxz, q dy plus y dq divided by 2qzy. Z can be removed, 2 can be removed. Now one thing you know from your childhood, that d of xy is x as it is, derivative of y is dy, plus y as it is, derivative of x is dx. This formula I think all of you know. So if I use this, I can write this as d of px divided by px, d of qy divided by qy. Okay. So this have already used. So function its derivative in numerator, function its derivative, integrate. So you will get ln px equals to ln qy. Constant, again I am, because I have to take a root at least once. Okay, so in most of the questions we have to do so. So let's take this as ln a square. Okay, if it will be used, this square will be used, then it's okay. If not, then also it's a constant only. A and a square both are constant. So bring this term to the left hand side. So ln px minus ln qy equals to ln a square. So you get log a minus log b is log a by b. So px by qy equals to ln a square. Now you can remove the log. So px by qy equals to a square. First focus is finding p alone. So if you find p alone, you get a square qy divided by x. Put this value of p in the original equation. Let's say this. So you get z square equals to, in place of p, put a square qy by x. A square qy by x qxy. qxy. Only x is getting cancelled. So z square is a square q square y square. Perfect. I want q. So q square is z square divided by a square y square. Let's see that taking this a square is finally benefiting us. Take root both sides. You can write plus minus. I sometimes neglect it, but yes, you have to definitely write it. So this is z divided by ay. I have got p, I have got q. You must be thinking of that very useful equation, which is dz is p dx plus q dy. That must be running through your mind. So let's hurry up and use that, because that is one of the last thing which we have to do in order to get to the answer. So because z is a function of x and y, so we write dz is del z by del x times dx plus del z by del y times dy. Now this del z by del x is known as p and this is known as q. So dz is, what is the p? It is a square qy divided by x dx. Okay, and what is your q? Wait. Coming to p, a px by qy equals to a square. So px by qy. So we have p dx plus q dy z by ay dy. Okay. So a is never there, or yes, it is there, z by ay. Now this z is again making me a bit confused, because if this z is there, one more z I wanted here so that I can send that z to that side, but I am not getting that. Here P is in terms of Q also. Okay. So that is something I am facing. That is why I am facing problem. So what I can do, here you have Q also. Now because you have got the value of Q which does not contain any other thing. So P is equals to A square. In place of Q put Z by AY into Y and X is in denominator. So this gets cancelled. So P, you don't want P in terms of Q. Remember, so P is equal to A squared Z divided by AX. Now this is perfect. I am not using that. So in place of P, A squared Z divided by AX. So this A and A again getting cancelled. So AZ by X. Fine. Now Z, bring this side. So dz by z, A is anyway constant. So A dx by x plus dy by y. Okay, and 1 by A is again there. If I integrate both sides, dz by z integration is ln z. Here A times ln x, 1 by A times ln y. Let's say another constant b comes. Fine. So let's name that other constant to be ln b so that I can find z alone. Now here you know the property of log, that if we have log x base a and if n is there, we can always bring this n to the power to get log x power n base a, and you can do the opposite thing also. So if I take this to the power, I will get ln z equals to ln x power a plus ln y power 1 by a plus ln b. Now log a plus log b plus log c, log abc. So I am getting ln z equals to ln of x power a, y power 1 by a and b. I can now remove log from both sides to get finally z as x power a, y power 1 by a and b. Finally a bit of relief for me because I have got the final answer. To summarize what we have done, first step, bring everything to the left, get your equation, get your function f. Then second step, write the charpit's equation. Now then find the elements of the charpit's equation, that is del f by del x up till del f q del f by del q. Then what you do, either use multipliers if grouping doesn't work there, and after using multiplier get a equation, okay, which you can put in this. In the previous question we saw we got exactly that equation, p square plus q square, we got exactly that. Sometimes like in this case px by qy you got, which is there, not exactly px by qy is there, so you just put that in equation, okay. So put that in equation, from there on get the value of p in terms of x, y, z. P in terms of q will not work, as you saw in this case. I was stuck there only. So find p in terms of x, y, z, q in terms of x, y, z. Use this very useful equation, dz is p dx plus q dy. There, from there on the work becomes easy. Log will always come into picture. Integration, you all know, there complexity can be there, but that is easy thing to do at the end of the day. The only thing, the charpit's thing which is difficult is to write that equation and find the value of p in terms of xyz, q in terms of xyz. So more and more practice will give you more and more clarity in this concept. So that's our final answer. Looking good. Z equals to x power a y power 1 by a times p. That's it from my side. Thanks and have a nice day.